Verifying trigonometric identities is the process of proving that the left-hand side of the equation is equal to the right-hand side. There are many ways you can go about verifying trig identities, but there are some guidelines for proving trig identities that can help start you off, especially if you're not sure where to start off. First, you should start with one side, meaning pick one side of the equation and write it down. You are trying to transform it into the other side, and again, it may be counterintuitive, but you should always start with the more complicated side. The more complicated side usually gives you more options than the simpler side. Second, use known identities. Use algebra and the identities you know to change the side you started with. Just algebraically and trigonometrically manipulate one side to get it to equal the other side. And third and most important, convert to sines and cosines. If you get stuck, try to rewrite all functions in terms of sines and cosines. I like to start off immediately with that, but you don't have to. That again is just the guidelines that you should use to help you along verifying identities. So let's start with this first identity here. Tangent theta plus cotangent theta equals secant theta cosecant theta. So neither side really seems to be simple, but I like to start with the left-hand side since it looks about the same difficulty. So I'm going to take tangent theta plus cotangent theta, and I'm going to try and get it to be the same as the right-hand side. So first off, I'm going to change these to sines and cosines. So tangent theta is going to be sine theta over cosine theta plus cosine theta over sine theta. Nice and easy. Next, I'm going to get a common denominator, which is just going to be sine cosine. So when I get a common denominator for these two fractions, I'm going to end up with sine squared theta plus cosine squared theta over sine theta cosine theta. It doesn't make a difference if it's sine cosine or cosine sine. I just like to go, typically it's in order sine then cosine. So I have that, and how am I going to work with this? Well, first off, the top, sine squared plus cosine squared. That needs to be immediate in your mind, that when you see sine squared or sine squared plus cosine squared, that you can use the Pythagorean identity for that. I know that sine squared plus cosine squared is going to equal 1, so I can substitute it out and say it's 1 over sine theta cosine theta. And now that I see that it equals that, I can break this up really nicely as 1 over sine theta times 1 over cosine theta. Well, 1 over sine is just cosecant, so cosecant theta, and 1 over cosine is just secant, so times secant theta. Now this is the exact same as the beginning, but it's not in the right order, but it doesn't matter, it is the same. However, if you really want to, and it's not wrong to, you can just rewrite the order. Secant theta, cosecant theta. Again, proving that the left-hand side equals the right-hand side. You don't have to rewrite the order like this, but if you want to, it's not wrong to. Now how about this one? This one looks like a little bit more of a problem. Cosine x over secant x plus sine x over cosecant x equals 1. How am I going to do this? Well, obviously there's not much I can do with 1. Very limited my options, so I'm going to work with the left-hand side. So cosine x over secant x plus sine x over cosecant x. And I'm going to work with this. I can't really do much as it is, but I know I have secant and cosecant, so let's change them to sines and cosines. So cosine x over 1 over cosine x, because secant is just 1 over cosine, plus sine x over 1 over sine x. And I'm going to flip these fractions here, so I'm going to have cosine x over 1 times cosine x over 1 plus sine x over 1 times sine x over 1. I can multiply the sines and cosines together. I'm going to end up with cosine squared x plus sine squared x. And again, I know that sine squared plus cosine squared is going to equal 1. And there we go. The left-hand side equals the right-hand side. And that's just what you do. Again, change things to sines and cosines and it'll make your life much easier.